Good morning friends, welcome back. Again we will have the CH1501 and unit 2B part now. Before we go for part B, few more topic, right, which is very important topic today. Either directly or indirectly they are going to be asked, right, internal or as well as the external examination friend. But before that, let me share with you some of the planning by our chemistry department. Friends, we have started in October, November, and we have what you can say the content for which we are asked to conduct your first internal examination, which is known as CIA1, Continuous Internal Assessment 1. So that will be done by 23rd of December, friend, and therefore we have decided that 21st is Monday and we will conduct your CIA1. It is MCQ based examination, friend. It will be conducted on Moodle, right? All those teachers, those who have taken lectures, right, they will inform you up to what they are going to ask, right? And suppose we are planning for 50 MCQs, you will be getting 1 hour time, maximum 1 hour time, right? And you have to respond. Friends, 21st, right, you have to have the what you can say Moodle logging. The time will be given to you. Before 10 minutes you get into the Moodle, right? You make sure that you are using laptop or personal computer or good electronic device, right? Not only good electronic device, it is your responsibility that you have to have very good net connectivity, friend. If you are using mobile, which I do not advise, friend, right, keep it horizontal, friend, keep it horizontal. Otherwise sometimes some what you can structure may not be visible to you, friend. Now this 1 hour is very important, friend, and by chance our mistake is there, right? You do not wait, you complete the MCQ examination first and then report it to me. That's question number this was wrong, right, or the option was wrong, something like that, friend. But first you complete, friend. And this is chemistry, there is a possibility of some typographical error, etc., right? The Moodle, right, is very important, very intelligent, I would like to say, platform. As soon as Atul sir or you enter, it will note down the time, at what time you are entering, what time you are completing your first question, going to the next one, something like that, friend. And Moodle, when we upload the 50 questions, suppose 50 questions are there, it may be 50 or it can be less than 50 also, friend. If 2 marks question is asked by a teacher, you can understand the marks will be 50, but the question will be less number. In any case, CIA1 will be, suppose out of ideally 50, will be converted out of 15, friend, 1-5. Similarly, later we will have planning for CIA2, maybe January, February, etc., friend, right? So well before we will inform you, and that CIA2 will be also internal examination and it will be conducted out of 50 marks, but it will be converted again into 15, 1-5. So 1-5 of CIA1, 1-5 of CIA2, total will be combined out of 30, friends. And out of 30 marks, 30 marks, you have to clear internal examination by scoring 11 plus marks, friends, right? So this is the information which I would like to share. 21st is the Monday, December. We will announce what is the time slot, right? There will be no clash with any other department also, friend, but you have to give your internal examination, friend, right? And for that, Moodle login is very important, because Moodle, there will be one quiz, or you can say title will be there, CIA1 with the date, and all the teachers will be contributing, those who have taken the portion, right, for this CIA1, friend. Again I am telling you, it can be 50 MCQ, it can be plus minus. Ideally we are targeting 50 marks, and then it will be converted out of 1-5 marks, right? Well in advance I will be telling you that up to what I have asked, right? I am preparing the MCQs, and that is why I will let you know little later. What is the characteristics of Moodle, friend? Moodle based examination settings are such that at the right time only it will open. First of all, we'll make sure that the quiz, the test may not be visible, the heading is not visible. 10-15 minutes before the time we will open it. It is visible to you, but it is not going to start. Suppose I have set the question paper at 12 o'clock, right? 11:50 you will be able to read, for example, that this is the examination, today's date, right? All these things. But when you click, it will say no, it is the starting time is already informed to you by department. Suppose 12 o'clock, before 12 it will not start, friend. Similarly, if it is up to 1 o'clock, after 1, whether you want it or not, it will get submitted, friend. And my suggestion to you is, suppose time is up to 1 o'clock, right, and you have done, then don't wait for submission, friend, right? The last moment, suppose there is some what you can say too much, what you can say, that for submission etc is there, some net issues are there. If it is done, submit, friend, right, at least 5 minutes before time, friend. Number 2, the question paper will be, question 1 is there, 4 option will be there. You try to choose the best option. One page, one question will be there, go to the next one, right? Now suppose you don't know what is the answer, you want to keep it for some more consideration. No, it will not be possible that you skip this question, move forward, and then lastly you come to the previous question. No, you have to answer, friend. It will not allow you to go back, friends. Number 1. Number 2, this is one connection with the previous property. Suppose you think that this is the question, suppose question number 5, I will try to search the answer and then I will answer, right? And let me go for 6, 7, 8, 9, 10, reaching up to the last. Now 5 is not available to you, friend. And not only that, your question number 5, right, will not be the same question number 5 for another student, friend. Question number will be changed, friend. It is automatic. It is property of Moodle. Not only that, suppose the question number 5, the correct answer is A, right? The value is 108, for example. When it goes to another student, it becomes question number 48. The option which was the correct, suppose at A, 108, right? Now for the other student, the question has gone to 48. The correct answer has gone to D option, friend, 108. This is known as shuffling, friend. And therefore, if you are stuck somewhere, right, you cannot say that, sir, my question number 5, there is some problem, because I don't know. Your question number 5 will be question number 15 for someone else. Therefore, you have to talk to me in terms of taking photograph etc little later. It will not happen, friend, believe me, right? But you have to talk with me what is actually that question you are talking about, right? Okay, so with this little instruction, friend, start preparation, right? Start preparation from day 1 onwards. I am going to give you some discount, right? Because I will take little survey, and what I will do is I will take decision in favor of you about my portion. I am giving you something from my portion. Well in advance I will announce up to from day 1 up to this you have to prepare. Today's point is again very important, friend. Last time we saw the reactive intermediates, friends. Carbocation, carbanion, free radical, right, nitrines, carbines, benzynes, etc. Having understood that these are the part of the reaction, let us try to understand types of organic reactions, friends, right? They are divided into 4 categories, friends. The first one is substitution reaction, friend, right? Actually we will talk about substitution reaction, friend, this one, right? It is also known as displacement reaction. But before that, let me give a little more idea that another division is your, what you can say, addition reaction, elimination reaction, or rearrangement reaction, etc., friend. So we are going to talk to you about addition, elimination, rearrangement, right, with examples, little more in detail, but just now introduction. The first one is addition reaction. Why I am skipping this one, friend? This is the main course for today's discussion, friend. That is why, right? Actually I thought I will take Google Meet lecture today, right? But 2 things which has not allowed me to call you on Google, but definitely by today evening, if I am getting all the emails of FIBSC, those who have chemistry, I would like to talk to you via Google Meet, friend, where you can unmute your mic and can ask the question, right? YouTube or this kind of video, it is one way interaction, friend, right? Not only that, before your 21st, I will have one doubt solving session for you, friend. From day 1 up to CIA 1 course, whatever I have announced, any question you can ask from that portion, friend. Getting this one? Okay. So first of all, this is the main part. I will talk to you little later. Addition reaction. Just we try to take introduction. So reaction in which atoms or groups of atoms are added to a molecule. Generally, this molecule will be having double bond, right? Unsaturation, right? They are known as addition reactions. Addition reaction occurs with the unsaturated compound containing double bond, triple bond, etc. This is ethene, friend. Addition of HCl getting chloroethane. So hydrogen is added this side, friend, and chlorine is added on this carbon. So this is your addition reaction. Getting simple introduction part of the term, friend. The second one is elimination reaction, exactly opposite to the addition reaction. Therefore, it is reverse of addition reaction, and it involves elimination or loss of atoms or groups from a molecule, right? And generally you know that it is reverse, therefore unsaturation is produced here. So this is your ethanol. In the presence of concentrated sulfuric acid, hydrogen is lost from this carbon, OH is lost from this carbon, that is CH2 carbon, giving you CH2 double bond CH2, and water is eliminated, dehydration, friend. In the presence of concentrated sulfuric acid, this is elimination reaction. The next one is rearrangement reaction, right? If I ask roll number 10, this is physical class, you stand up from bench number 1, go to the third bench, and third bench, if I ask please come on the first bench, I am not allowing anyone to enter, right? I am not allowing anyone to leave the class. So total number of students are the same, but what has the changed? The arrangement, sitting arrangement is changed a bit. This is what do you mean by rearrangement. In terms of chemistry, rearrangement reaction means a type of reaction in which atom or group in a molecule rearranges to form a new compound, friend. For example, here 3-chlorobutene, right? This is our starting material. This is carbon 1, this is carbon 2, and this is carbon 3. So this is your 3-chloro-1-butene or butene getting converted into 1-chloro-2-butene, friend, right? So what is the situation, friend? See, this chlorine has shifted here on this carbon, and the double bond has moved one step back like this, right? So this is your carbon 1, chlorine is there, carbon 2, a double bond starts, therefore it is 1-chloro-2-butene. Molecular formula is the same. So this is one example of rearrangement reaction. Starting material and product, they are two different compounds, friends, right? So this is what do you mean by a rearrangement reaction, friend. As I told you, friend, the most important part is this particular slide where we are beginning with substitution reaction, friend. Substitution reaction, or it is also known as displacement reaction, right? So this replacement of an atom or group from a molecule by different type of atom or group is known as substitution reaction or displacement reaction. They are mainly divided into following groups. Substitution reaction, they are two types mainly: free radical substitution reaction. The other side you have ionic type of substitution reactions. What do you mean by free radical substitution reaction, friend? You have already come across the chlorination of methane in the presence of light. You got first step chloromethane, further chlorination in the presence of light, dichloromethane, further chlorination, trichloromethane, chloroform, what do you know? And the last one is tetrachloromethane, that is carbon tetrachloride in the presence of light. So stepwise chlorination in the presence of light, and you know that you have used this kind of symbol H mu. They occurs via dot mechanism. Dot mechanism means free radical mechanism, and that is why every step one hydrogen from methane was eliminated or substituted, replaced by chlorine atom. That is why it is free radical substitution reaction, where the reaction mechanism takes place via free radical formation. The other side you have the ionic substitution reaction. They are subdivided into two. One is electrophilic substitution reaction. Here the electrophiles are involved, friend, and this is 12th chemistry, friend, nitration of benzene, right? Then you have sulfonation of benzene, halogenation of benzene, Friedel-Crafts alkylation, acylation. These are all electrophilic substitution reaction. More precisely, you can say electrophilic aromatic substitution reactions, friends. Now coming to the main part. This is the main objective of today's session, friend. Nucleophilic substitution reactions. Here a group is replaced by incoming nucleophile, right? This is known as nucleophilic substitution reaction, friend. We are going to see it in detail, friend. Nucleophilic substitution is nothing but replacement of atom or group by incoming new nucleophile, right? It is known as nucleophilic substitution. They are divided into two groups, SN1 and SN2, nucleophilic substitution unimolecular and nucleophilic substitution bimolecular, friend. So in the next slide, next 2 or 3 slides, we are trying to cover this portion only, friends, right? Let us see. One more identity, friends. Electrophilic substitution reactions are those which involves an attack of an electrophile. I told you nitration, halogenation, sulfonation, Friedel-Crafts reaction, etc. What do we know? Nucleophilic substitution reactions are those, right, which involves attack of a nucleophile. Nucleophile comes with a pair of electron and living group goes away with a pair of electron. We are going to see that reaction wise. So nucleophilic substitution reactions are divided into two, friend. For FIBSE, they are SN1, substitution nucleophilic unimolecular, or nucleophilic substitution unimolecular, the same, right? Either you use this word or the other title, meaning is the same. Similarly, nucleophilic substitution bimolecular or substitution nucleophilic bimolecular, SN2, friends. So these are the two symbols, friends. Nucleophilic substitution unimolecular, SN2, nucleophilic substitution bimolecular. Let us try to understand what do you mean by SN1, substitution nucleophilic unimolecular. Let us take one common example, simple example first. Reaction between tertiary butyl bromide, this is tertiary butyl bromide, with NaOH, giving you tertiary butyl alcohol. So this is the, there is no 2, friend, here, it is only OH. So this is nucleophilic substitution unimolecular. Why this is known as SN1, that we will see. But if someone asks, give one example only of SN1, you can immediately say that tertiary butyl bromide, when it reacts with NaOH or KOH, giving you tertiary butyl alcohol, is example of SN1, friend. Byproduct is sodium bromide, friend. So this is plus sign, friend, here you can put as a byproduct. Okay, let us try to see the mechanism part. In case of the mechanism, first step is heterolysis, friends. Hetero means unequal, lysis means to break, friend, right? Therefore, here what is happening? The CBr, that is C-Br bond, undergoes heterolysis from the starting material tertiary butyl bromide in a slow process. So this is slow step, friend. Step number 1, but it is a slow step out of the possible steps, friend. So this undergoes heterolysis. It breaks uneven. Br takes away both the electron from the bond, right, becomes Br minus. This carbon, the central carbon, which has lost its own electron, will become the positively charged. So the carbon ion is formed, carbocation is formed, or carbonium ion is formed, friend, sorry. So this is the intermediate structure form. Now we know that carbocation, we already discussed the reactive intermediates, friend. Tertiary is the most stable, then secondary, then primary, then methyl carbocation, right? So this is one of the stable carbocation is formed here from the starting material, friend. In the second step, what will happen? The nucleophile, incoming nucleophile, attacks the carbonium ion, because this is electron deficient carbon, friend. And the reagent which is coming out is coming from outside is with the pair of electron. So it has excess of electron, incoming nucleophile, there is an electron deficiency here, the marriage is possible, something like that. Positive charge, opposite side negative charge, or excess of electron, combination is possible. So the second step, nucleophile attacks rapidly to the carbonium ion, right, which is formed in step number 1 to form tertiary butyl alcohol. Here the OH can attack the carbonium ion from either side. This is side A. If the OH, from where you are getting, from NaOH or KOH, if this is the root, then this particular product will form, friend. Or the OH minus ion can attack from side B. Side B means what? Actually from where the bromine actually it was attached, friend. Here it was bromine. Now this time this OH minus can attack from that particular side, side B, friend. If it attacks from B side, this particular product is formed, right? And therefore, in case of B, here it was bromine and now it is OH. So this is known as retention of configuration. In this case, what is the situation? The OH is coming or taking place, which is exactly opposite to the leaving group. Actually bromine was attached here. Now the OH, incoming nucleophile, is exactly from opposite side. This is known as inversion of configuration. So tertiary butyl alcohol is formed, but partial product is with retention of configuration. Here it is this. This is inversion of configuration, friends, right? And this step is fast step, right? Immediately once carbocation is formed, OH, incoming nucleophile, either from side B or A, will attack to form the product, friend. Okay, so this is the potential energy level diagram, friend. First step is low, it is rate determining step, and you have seen that there was only hydrolysis of tertiary butyl bromide. Only one chemical is involved in step number 1, which is the slow step. Therefore we can say that from the first step it is clear that the rate of reaction depends upon only the concentration of the substrate, tertiary butyl bromide. Because it is slow step, nothing else involved in that. Therefore it is known as unimolecular nucleophilic substitution, because overall rate of reaction will be decided by step number 1, where only one chemical is involved. Therefore it is unimolecular nucleophilic substitution reaction, and it is denoted by SN1, friend. So potential energy level diagram, friend, this is energy axis, this is reaction progress, friend, right? So what is the situation, friend? We would like to give the energy in such a way that the bond between carbon and Br goes hydrolysis. So this is the, what you can say, stage where we are providing the energy, formation of carbocation here, somewhat stable, right? Then there is a formation of a bond between carbocationic carbon and OH minus ion, releasing somewhat the energy and getting converted into product. This is your starting material, this is carbocation, and this is product, friend, right? So this is how we can explain SN1 reaction mechanism, friend. If this is physical class, I would have asked a couple of questions, friend. One of them is, what is the full form of SN2? It is bimolecular nucleophilic substitution reaction or substitution nucleophilic bimolecular. One is the same. Simple example is reaction between methyl bromide and sodium hydroxide, friend, giving you methanol. So this is methyl bromide, NaOH, giving you methanol. Let us see what is the reaction mechanism. Here also byproduct is sodium bromide. This is the structure of methyl bromide, OH minus. Friends, here OH minus attacks the carbon atom, central carbon atom, in its first step itself without bromine to leave the carbon. So the bromine is bulky group, so OH minus is left only one situation, that it attacks from back side, right? I am talking to you from the screen front side. Imagine that OH minus attacks the screen from the back side, like that, friend, right? So bromine is bulky group, so the OH minus is also bulky compared to hydrogen. It will prefer to approach this carbon from the back side. So there is a formation of pentavalent transition state, friend. As this central carbon atom, right, which it was fully connected with Br because of having tendency Br to become Br minus, and OH has tendency to have the donation power of the electron. The carbon, because of electronegativity, and bromine leaves or wants to leave in the form of Br minus, this becomes partially positive. This fellow says, okay, I have the excess electron, let me approach this central carbon atom. So this dotted line means initially this carbon and bromine 90% they are connected. At that time 10% attraction or attachment with the OH minus to central carbon atom. Then this is 30%. CBr bond is 30%. Now this is 70%, this is 30%. At one point of time the bonding between carbon and Br is 50%, this is also 50%. Now Br has already decided that I want to leave, therefore the carbon and Br only 10% connection is left, this will be 90%. One point of time whole Br is left and complete connection with OH with the central carbon atom, giving you methanol as this product. So this is pentavalent transition state, friend. It is unstable or momentary arrangement, friend. Here hydroxyl ion attacks methyl bromide carbon from the side which is opposite to the leaving group. This gives 5-member transition state which loses bromide ion rapidly to form methanol, right? So in this step Br minus is lost, friend, right? The transition state dotted line indicates that formation of a new bond between carbon and hydroxyl group and breaking of old bond between carbon and bromine take place at a time. This process gives final product whose configuration is opposite to that of the starting material or reactant. This is known as inversion of configuration, friend. The rate of reaction depends upon the concentration, because only one step is there. Both the reactant, that is methyl bromide as well as NH, therefore it is known as bimolecular nucleophilic substitution reaction or SN2, friends. The potential energy level diagram is as shown here, friend. So this is methyl bromide, this is pentavalent transition state. Then bromide ion is lost, you are getting methanol, friends. So this is energy axis, this is reaction progress, friends. Okay, let us try to see your understanding. If this is physical class, I would have asked, right, please explain what you have understood by giving me 1, 2, 3, 4, 5 differences between SN1 and SN2. So SN1 and SN2, first difference itself, the name itself. Substitution nucleophilic unimolecular, you can write here substitution nucleophilic bimolecular. SN1 involves 2 steps, SN2 1 step. There is a formation of positively charged carbon, that is carbocation or carbonium ion. Here there is no formation of carbonium ion. Instead of that, if you want to write, you can write there is a formation of pentavalent transition state, friend. Yes, this is identity of something. What happens as intermediate or intermediate stage? There is a partial inversion in the final product. We know that the OH minus can attack carbocation from side B as well as side A, 50% retention of configuration, 50% inversion of configuration. Here there is no chance. OH goes exactly from opposite side with respect to where the bromine is attached. Therefore, there is a 100% inversion in the final product. The rate of reaction depends upon only one chemical. Here rate of reaction depends upon 2 chemicals. Now bulky group favors the reaction. How it is? I will tell you. See, we selected tertiary butyl bromide because when carbocation is formed, right, more organic group, then positive charge will be more stabilized. Not only that, the first step, which is removal of bromide, it is favored if there is a bulky group surrounding to the central carbon atom. Whereas the opposite side, friend, small group favors the SN2. Why? Because in first step itself, OH has to reach the central carbon atom, and if the central carbon atom is surrounded by big group, then OH minus cannot approach to central carbon atom. Therefore, small group like hydrogen, methyl bromide favors the SN2, friend. The rate of reaction decreases as tertiary, secondary, primary and methyl bromide for SN1. here the rate of reaction decreases exactly opposite. Primary, that is methyl bromide, then primary, secondary, and the least is tertiary butyl bromide, friend. Again it is the same situation, friend. When you have the tertiary alkyl halide, right, the reaction is fast. Why? Because the bromine will be leaving very fast, which is the first step, and you know that first step is slow. So how the structure helps? Because the tertiary alkyl halide, the groups surrounding to the central carbon atom will help to push the bromide in the form of Br minus. Not only that, carbocation is formed, again it may be stabilized by the groups like electron donating group. So tertiary will be the fast and this will be the least. Here you know that methyl bromide allows the OH minus to approach without much hindrance because of 3 hydrogen atoms are there. So the rate will be the very fast for methyl bromide, and it goes on decreasing as primary, secondary, and tertiary. Sometimes tertiary may not undergo SN2 type reaction at all, friends. Sometimes polar solvent favors the SN1 and non-polar solvent favors the SN2, friends. Let me tell you why. Actually, what is solvent? When you add solvent, what is the benefit of that one? When solvent is there, friend, then the mobility of the chemicals, that is the reagent and reactant, right, will be fast. When you add polar solvent here, friend, right, in SN1, right, SN1 you have the positively charged carbon atom, isn't it? It is a fully positive. Now this is one solvent. Suppose I am adding one solvent which is polar. Polar solvent means it will have one end partially positive, the second end partially negative, like HCl, etc., friend, right? Here I am not adding HCl, just I am telling you the polar solvent like ethanol, chloroform, etc. So this is the one molecule of polar solvent. What it will do, without you say it or not, it will direct its negative end towards the centrally positive charged carbon atom, and the positive charge will automatically remain away. Another molecule of this solvent, again what it will try to direct, orient its minus end towards the positive charged carbon atom. This minus and this positive, they are going to have the attraction, friend, isn't it? And therefore the positively charged carbon atom will feel good, and it will start the message to the starting material, and it will invite the tertiary butyl bromide come into the, what you can say, carbocation stage. We are having friend that are going to help us by extending negative ends towards us, and therefore we are stabilized. What it says? It is said by the positively charged carbocation. Therefore this is slow steps. Carbocation formation is slow step, but when you use more and more polar solvent, what will happen? It is favors the hydrolysis and formation of carbocation, friend. In case of SN2, non-polar solvents favors SN2. I will tell why. See, friend, in case of SN2, there is no formation of carbocation, correct? Only addition of solvent, they will increase the interaction. But why you are asking that non-polar solvent favors? What if I use the polar solvent? See, friends, this is methyl bromide and you are adding what? OH minus, isn't it? Now by chance, if you are adding polar solvent, friend, this charge, which is minus charge, came from the NaOH, the polar solvent will stabilize that one, right? What they will do? They will extend its positive charge towards this particular negative part of your OH minus ion. Therefore now OH minus is not interested to react with methyl bromide. So reaction becomes slower and slower. Therefore non-polar solvents, right, like benzene, CCl4, etc., they are going to favor the SN2 type of the reaction mechanism, friends. Thank you.